I'm Matt. I'm your new friend, or your old friend, but I'm your friend. It says it on the slide. That means it's true. I like to wander. I'll try not to. Is this last time I had to stay in one space so the light could see me? Can you still see me when I do this? Yes? Fantastic. Okay. So this is a big mouthful. Design, behavior, and organizational patterns that will make a real impact in your company and code base. What this really means is, Taylor said, why don't your talk be this one thing? Because I came in with a couple talk ideas, and I was like, this, or this. Why don't you pick based on what's going to be the best fit? He said, pick this. So I started writing a talk that then it turns out was going to be the same talk somebody else gave. I had an even better idea about what this is going to mean, so none of you are going to know what it means because I didn't even know when I wrote the title of the talk. But we'll get there. It's going to make sense, I promise. The goal here is to not talk about design patterns, because there's a design patterns talk later today, and it's going to be awesome. I've already talked to him about it. It's wonderful. So he's going to cover that. So rather, I'm going to talk about the design patterns that we don't think about. And really what that's going to come from is I spend a lot of my time reading other people's code. That's not actually me at the body level, even though I do dress up well in a suit. That's an IRS auditor, because I audit other people's code. Yes, that was awesome. And so I spend a lot of other time reading other people's code, whether it's my developers or whether somebody hires us to come in and audit their code base. That's something that happens with us at Titan a lot, is someone says, we bought this code base from somebody else, or we just fired our lead developer, or we've been doing this on our own for a while and we don't actually know how to do it well. We need your help to come in and tell us, are we doing it right? What mistakes are we making? How do we fix these queues that are timing out or whatever else? And so I, or sometimes one of our seniors, will come in and we'll read through the whole code base and we'll tell them, if you change this, if you redo this, or here's what's causing you that pain or whatever else. So I'm very used to reading other people's code, identifying the things that are causing them pain, and then recommending A, things that they can do to fix it, and B, things they can do next time to not run into that problem in the first place. So when I talk about patterns that pay off today, I mean things that are going to need you to call me in less later. So I'm basically making Titan less money. And I literally almost didn't write this talk because I was like, if I give this talk, less people will need us to audit them. Oh well, let's do it anyway. So this is actual money stuff. I really think this is going to help you a lot. So when we talk about pattern, it's one of those magic words that we throw around a lot and we don't actually always know what it means. And so I really, really hoped that this was going to be true, and it is true, is when I went to the dictionary, there were two definitions, and they were the two that I think of it as being, which was perfect. The dictionary kind of made my point for me. The first one is a regular and intelligible form or sequence discernible in certain actions or situations. So think about pattern matching or pattern recognition. You see a thing and you notice that it's similar. It's a pattern. So that's the first one. But the second one is a model or a design used as a guide in needlework or other crafts. Think about every time you make a dress. You don't make a dress from scratch. You take the dress pattern. So it's a shape of a thing that's predicting what you're going to do. It's telling you what to do. And those aren't the same. There's consistency, but one of them is a little bit more of a template, and one of them is a little bit more of identifying something that is outside of your control that's happening. And so in our context, what I want to think about is that the first type is more about the problems that we identify in our code bases, or the things that might lead to problems. And the second type is more about the solutions. So there's the template of a solution, there's the repeated problem, or the repeated thing that might cause our problem. And I think that what we need to do as we're thinking about this is we need to have the right posture towards how we approach these things. And this is not actually the right words. I'll talk about it in a second. You'll probably have an opinion of the better words I should have used here. But I've started to look at the patterns that are more prescriptive as preventative versus reactive. And as I talk about patterns, you're going to recognize that some of these patterns are more preventative. So think about preventative medicine. You, for example, eat an apple a day or whatever, and then the doctor goes away or whatever. And then the other ones are reactive medicine. Something goes wrong, and then you get medicine in response to it. So I want to think about our patterns in kind of that same way. So when we think about preventative patterns, it's something that you should do on every single app, no matter what. So like floss every day, or avoid N+1 queries, or don't use env calls in your non-config code. Every single code base should do this all the time. And some of the things I'm going to tell you today, you should do on every single code base all the time. But I'm not actually going to tell you which are which, because you need to make those decisions about which you're always going to do and which you're going to do in response to problems. And that depends on who you have on your team, what resources you have available to you, how much money you're able to bill, what your technical skill looks like. They're not going to be the same for everybody. So you need to make this decision. And then some of them are reactive patterns. You feel the pain, or you see the pain, or you're about to introduce a new piece of architecture that you know will have that pain. For example, you have a root canal to treat cracked tooth. You don't want everybody to have root canals. That would be awful. I've gotten 2 of them. They're terrible. Or, for example, you introduce a microservice to isolate slow adapter infrastructure. You don't just do microservices all the time because someone told you about it. You do it because there's a need, and then you meet that need with microservices. Or, for example, you use the factory pattern. You don't use it because everything should be the factory pattern. You use it because you need to normalize multiple exchangeable implementations or whatever else. You're probably familiar with the saying, if all you have is a hammer, everything looks like a nail. So what we kind of tweak this into is if all you have is a command bus, everything looks like a command. If you've ever read anything or watched anything from Jeffrey Way, you hear him talk about the fact that every single time we learn a new pattern, we get really excited and we use it everywhere. And we're like, oh my gosh, I'm going to do command buses or DDD or whatever else all the time. And that's what this leads to, is assuming that because somebody talked about something, that means it's necessarily something you should use all the time. And then that leads to hyper-architected code bases that are very, very rigid and very hard to actually make changes to. Underlying everything I'm saying today is YAGNI, which you've heard about already, or KISS, keep it simple, or all these different things that really are suggesting to you that don't do stuff you don't need. And you don't know what you need always. You don't know the fullness of what you need until you're actually writing the code, until you're actually seeing the problems. And sometimes you can start to understand, well, every single time I need to avoid n+1 queries, okay, so some of them are preventative, but most of these patterns are things you do in response to something. There's a fantastic talk at Laracon EU 2015 by somebody whose name I'm bad at pronouncing, Konstantin Kudryashov, called Min-Maxing Software Costs. And I've started referring to it in almost every single talk I give because it's that good. And what he ended up saying basically was we should architect our code bases to plan for the future. And usually there's different ways that we do this. And some people say, well, because the cost of change, which is how difficult it is to make changes to your code base after it already exists, is the most important thing. Because you have the cost of introduction once, right? You introduce a new feature, it's there, and it happened once. But you have the cost to change that feature for the rest of your life. So cost of change is more important and exponentially more so because your code base gets more complicated over time. So because the cost of change is so much more important for you to optimize for than the cost of introduction, then a lot of people get really excited about really focusing about the introduction. And one of the things they often do is make the cost of introduction really difficult out of a desire to make the cost of change go down. The problem is it doesn't actually work, because you can't predict the future. Upfront design, or everything inherent in Waterfall, which is why we all hate Waterfall so much, is the idea that you can control the cost of change by applying enough analysis or architecture or whatever else up front. The problem is, it's not actually true. You can't predict the future, you don't know what's coming, and so what you end up doing is making a really rigid system that has just as much trouble with the cost of change, because the change that comes is not the change you're expecting, but now it's way more complicated and way more architected and a lot harder to change. Go watch that talk if you get a chance. This is the key right here, and I'm going to thank Logan, who actually read Logan Henson at Titan read the early version of my talk, and he wanted me to focus on this, so I made a whole slide for it. And this is key. If you write code that is easy to delete, then it is easy to change. Because if you delete it and rewrite it a little differently, or delete it and put something else in its place, then you changed it, fine. But if you write hyper-architected code that's so enmeshed because you are going to predict the future, then when the future comes and it's not what you thought, it's very difficult to delete because everything's kind of going like this. So focus on simple code that does just what you need right now and make it easy to delete, so when the new code comes along, the new project requirements come along, which is the moment when you actually know the future because you're in the future, then make the changes. So make those changes easy to make early up front. One of the key things I want you to know about this talk before we get into the patterns is that the payoff is more important than the patterns. I care less that these patterns are right or wrong. Some of them, actually all of them, I completely made up. A few of them I made up, and they kind of used some terms that people have used before. Sometimes I probably used terms people have used before and I used them wrong. That's not the point. The point of this is that you understand that the whole goal is to help you write better software, to meet the needs of your users better, to meet the needs of your administrators better, to do your job better. Whatever it is, those are the goals. The goal is not patterns. The goal is not architecture astronautitude. The goal is just to do it well, so don't focus on the patterns. I'm going to give you some patterns, and they're cool, they're great, but the goal is for you to do a good job, not for you to learn more patterns. All right. Now, let's talk about the patterns. You have the right attitude, I hope. So I'm going to talk about a few of the patterns that we either use at Titan or that we use in response to code that we're running into. So we either do them up front or we do them in front of problems that were actually happening. I have separated them into 3 types. I made up this 3-type thing again, so don't worry about this, but it just helped me think about it. And the 3 types I have noticed are process, architecture, and factoring/refactoring, and they go from the biggest to the smallest. Process is about how you work together as a team. Architecture is about how you plan your code bases and the pieces that connect together. And factoring and refactoring is literally looking at a 200-line controller method and go, oh my God, how can I make this better? So we're going to start big, we're going to go small. Hopefully we don't run out of time. If we do, I'll put the slide deck online later. Number 1. Process patterns. I want to thank Noemi Olvera, who works at Titan, for being an amazing illustrator, especially when she does illustrations that don't make sense to anybody but the tiny portion of the world who's obsessed with the movie Minority Report like me, which is what this one's about. And she just works with it, but it doesn't even make any sense. So precogs and minority, yes, she's amazing. She makes me look like I know what I'm doing. Also, thanks to Steve Shoger, who did the original layout of these designs. If you use hero patterns, you recognize the maps in the background. So precogs in the Minority Report are people, and there's 3 of them, and they lay in a little bath, which is why you see the 3 people, and they can tell the future. So literally the whole point is you can't tell the future, but you think you can predict the future, and which is why we have all sorts of process problems all over. So capital A, Agile, rather than Agile, which we'll talk about in a second, Waterfall, hyper-architecture, crazy architected things that are super rigid. The problem that these all come from is that we think we know what's coming. Oh, I anticipate because I saw this happen in a code base once that we're going to need this, this, and that, so I'm going to write this really complicated system. And then what comes down the road is completely different. So I've already talked about this list a little bit. I won't talk about it more. You can't predict the future. Stop pretending like you predict the future. Take what's in front of you, do a good job with that, move on, take what's in front of you, do a good job with that, and that's it. And your life will be so much better if you just hang on to this, no precogs. And the payoff for no precogs is you're not going to commit to unrealistic timelines. You're not going to have unhappy clients when you can't deliver according to their timeline, or you get to that point where you say, well, we told you it was going to be $50,000 and now it's going to be $75,000. Or if you're this sort of company, you say, hey, devs, we told them it's going to be $50,000 and it's going to be $50,000, so you got to work 80-hour work weeks for the next 3 weeks to make up for my salesperson's mistakes. So just don't predict the future, and then you don't have to have those problems. You don't over-architect to try and reduce the cost of change, and you don't become rigid. You can continue flexing with new requirements because you only build for what you have in front of you. Instead, you can just do the best work with what you have, and that's it. It takes a lot of burden off of your back to do this anyway. The next one that's an amazing illustration is called code-based consistency. Code-based consistency is about establishing and enforcing standards across your code bases, across the various pieces of your applications. So imagine if you have consistent code style, consistent organization of your code base, consistent packages. You say, hey, every single time you need XYZ, just grab this package. You don't have to audit all of them every time. This is the one we use. Okay, great. Maybe you have naming and branching strategies for your version control, and you just say, this is how we do it at our company. Pull request strategies. When you do pull request, who has to review it? What should it be named? What should the pull request descriptions look like? If you have all these things relatively normalized, I'm not saying a super strict system, then new developers that come on board can understand it. Actually, I think I put this in the next one. Oh, no. I'll talk about this in a second, but this is a key for me. I don't want to be able to know who wrote the code just by looking at it. Your magnum opus is not your code style, whether you put braces on a new line or the same line or something like that. You are a creative individual who has creative potential much greater than where you put your braces. So allow these things to just be consistent and boring. Stick with PSR2, just let that be a thing, and then go be creative in actually solving people's actual problems. And so the payoffs you get here is it's much easier to onboard new devs to your company or to your projects because it's the same as all the other projects at your company. There's less cognitive load when they enter because they don't spend all their time trying to figure out, well, where does this live or how should I type this thing? The cognitive load is now on understanding the domain and understanding the people who actually care about what you're delivering, not where the braces go. It's a lot easier to ingrain good patterns on new devs because it's the same everywhere. So they're not like, well, if I work with Matt, it's this way, and I work with Samantha, it's this way, and I work with Keith, it's this way. Now those things are always going to slip in a little bit, but preferably those things won't be code style or where your folders go. And your devs spend their brain power on stuff that matters. Devs have limited amounts of brain power, and if they're spending all their time trying to figure out where the braces should go or whatever else, they're not spending it solving problems. The next one is bin scripts. This is something that does not come up very much in our world, but it's much more common in Rails and a couple other the front-end or the dev communities. What this means is create shell scripts for common tasks in your code bases. So for example, you have a bin folder under your actual version control, and you have an init.sh or an update.sh or a deploy.sh or a pre-commit.sh. And think about the things on the average code base that you run every single time you clone it down. Well, how many times has a new developer joined the project a year down the road and sat and thrashed for 7 hours because they didn't know that you were supposed to run Bower install because who still uses Bower? But it was there on that one. So if your developers instead know every time I come to a new code base, I do ./bin/init.sh, enter, and then I'm set up and I'm ready to go, your life's going to be a lot more easier. It's just a lot easier. It's the same way as kind of Forge where you have those auto-deploy scripts, but it's actually committed into the code base. So here are a few examples. You can see one on the left side, which is an init.sh, and these are all the common things you're used to. I'm going to take a drink of water while you read this. Composer install, copy over the .env files, artisan key generate. That is not even in a new code base. Every time I start a code base, I forget these things. And you get similar things for update. When you're updating, you might forget, you might just want to have the pattern of every single time you pull down, git pull rebase from, you might want to always run updates so you make sure you don't accidentally miss the fact that somebody introduced new composer dependencies or whatever else. So easier onboarding and less cognitive load when entering a new code base. We're seeing these things sounding pretty consistently. Spend less time wasted on, oh, it works for me, why doesn't it work for you? And honestly, the steps to onboarding, which you might be putting in a wiki somewhere, or might you be putting in your README, problem is devs don't read docs. Let that sink in. Devs don't read docs. It's sad, it's terrible, hopefully we'll fix it, but they will read the code. And if they see the code has init.sh, they're much more likely to actually run it. All right. The next one is called 4 eyes, and while I have laser eyes right now, I used to wear glasses, so this is not just a slur, I promise it's an actual real thing. No code should be merged to production without 2 sets of eyes on it, and if you have 2 sets, that's 4 eyes, and look at the asterisk down at the bottom. If any of your team members have more or less than 2 eyes, you can modify this number, but in general, it should be 4 eyes. Daniel Colborn. Normally what this looks like for us is you have 1 developer, and then you have 1 reviewer. So the developer writes the code, they put up the pull request, and they assign either the other developer of the project, or they assign one of our seniors, or they assign me to review the code. But sometimes that means 2 pair programmers. That's still 2 sets of eyes. They're writing at the same time. So if 2 people are pair programming, they pull a pull request, you just merge it because 2 people saw it. And you get a lot of benefit from this. You avoid the negative consequences of hyperfocus. And again, pair programming does this for free because one person's writing the code and the other person's thinking. But if you're not pair programming, one person writes the code, the other person was not there when they were trying to deal with that really gnarly bug and didn't notice the fact that they introduced some other bug because they were hyper-focused. The other person goes, whoa, did you notice that you left like 5 DDs in there or whatever else it ends up being? And so you get 2 people with 2 different mindsets, 2 different perspectives who are approaching this. And for that reason, reviewing brain is often very different from writing brain. Not even 2 different people, literally the same person. When you are writing code and you're fixing problems and you're refreshing over and over and over again and running your tests over and over again, you have a different perspective than you do when you're reading a diff in GitHub. And any 2 human beings have different perspectives. They have different experiences, they have different backgrounds, they have different ways of thinking, they have different training, they got a different degree in college, they may not have gone to college, they may have traveled the world. They see things differently, and those things allow us to approach our code differently. And those differences help us do a better job of solving problems. And this was somebody else, it might have been Daniel as well, I'm not sure, you share the load of responsibility for all code introduced. And that sounds kind of silly because, well, of course, like, you wrote the code, but sometimes when something breaks or you're worried about something breaking, it can introduce kind of pain in your shoulders. Well, I introduced that, and now I have to wait and hope for a couple of days it doesn't break anything, whatever. Having multiple people having looked at it means multiple people who have that little responsibility, and that does not have 0 consequences. There's a bonus tip. If you add 2 more eyes on, every single time you put up a pull request, you should read the diff in GitHub before anybody else sees it, always. And you will catch those DDs and those console logs and those missed, little typos and the extra semicolon and the extra letter A that you typed when you're trying to switch to Slack or whatever else it ends up being. So read your code before you ask anybody else to read your code. All right, our next pattern is document the weird. So there's a little bit of a running fight within the PHP and Laravel communities. If you don't know, PHP is split between people who want it to be more like Java and people who want it to be more like Ruby. Laravel leans a little bit more in the more like Ruby. We're not all, although I know plenty of you are doing type hints and return type hints and doc blocks and all that kind of stuff. But the doc blocks are the ones that seem the least useful because literally they're not parsed at all. And they get out of date and there's all these problems. Okay, I don't care if you use doc blocks or not, but I do want to say that if you do use doc blocks, the key that you should be doing is making sure that your doc blocks are all up to date, they're all useful, and you at least have the weird things documented. So if you doc block everything, that's awesome, that's great. Please at least keep them up to date because the moment someone sees 1 out of date or 1 useless doc block, they're going to ignore all the rest of them. So the key here, and what we do at Titan, is we don't doc block everything. We doc block the things that need doc blocks. So we don't have anything that says show the resource because I know it shows the resource because it's a method called show and the first property is the name of the resource. So that doc block doesn't help, so I don't read it. So later I don't read the doc blocks that do help. And so it's actually a problem. So what we do is we document the things that need documentation. So every single time in a Titan code base, when I see documentation, I say that's something I need to read. And so if you do that, then it says exclude the connections that match both user ID and service ID, and it's a 7-line long database query thing that's going to take me forever to understand. I now read your 1 comment. I knew it's good because you only block the things that matter, and I know that I now understand how this really complicated thing works, and you couldn't have fixed it just by writing self-documenting code because sometimes it's just complicated, although if you can write self-documenting code, do. And so now I know what it is and I move on. So document what is not obvious. I would recommend you also don't document what is obvious because then people don't pay attention, but that's your call. You have less wasted lines, you have less visual debt. Hat tip Jeffrey Way on that one. And you record business priorities as well, because almost always when you're documenting the weird, you're either documenting a bug or some piece of the code that didn't work the way you were expecting it to, so great, everybody learns, or you're documenting business priorities. Someone says, wait, why on earth does it do that? Almost always the documentation above it should say, client asked for ABC thing that didn't make sense to us, but it makes sense, and now, oh great, now I understand the business better. So those pieces of documentation are the best pieces because they encode all sorts of very valuable stuff in them. Lowercase agile. This deserves an entire talk. This deserves 5 blog posts. I will write this blog post when I get back. But I have been calling this concept that I have, lowercase agile. What I mean is not agile. You notice I pronounce it differently. There was no capital A when I said it, and it was agile, not agile. And when you hear someone say agile, they almost always mean Certified Scrum Master 3000, blah, 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 and they don't mean the Agile Manifesto. And I'm not saying that Scrum is bad, I'm not saying Scrum Masters are bad, I'm not saying Agile is bad, but I'm saying more often than not, I see it introducing problems into our clients. More often than not, when I come into a new client and they're doing Agile, we end up having to help them fix their process. And again, often we help them fix their process and it's great. Often those people, if they didn't have Agile, would be working in a worse spot. I get it, that's fine. So whether you choose Agile or not, you could use more Agile. So go read the Agile Manifesto and figure out what it is. But the Agile Manifesto is more about agility. So you think about, gee, Spider-Man super is agile. It's supposed to say sure is agile. Not I'm a certified Scrum Master, Agile 3000. So it's about lightness, responding quickly, encountering new things and then incorporating them into what you're working on. You know, it's about a militia versus a large army. Now, again, Agile can be helpful because if you've got a lot of people, it's gonna feel like an army. But take your Agile and make it a little bit more agile so that your large army doesn't feel as large and army-like. So you get the promises of Agile. You react quickly to new stimuli, you deliver functional iterations early and often, flexibility around different workers and different projects, all the things that Agile promises, but you don't get the costs of Agile. Things like, well, I can't pull that task because it'll mess up the burn down chart. Or people who don't actually have the opportunity to focus on delivering software because they spend all of their mental cycles, you know, the same thing we're talking about here, worrying about the system and the charts and the graphs and that kind of stuff. So stay agile. Again, I'll talk a lot more about that in blog posts and stuff later. All right, the next chunk, we're focusing down a little bit more on the code base, a little bit less on the process. We're going to talk about some architecture patterns. The first one is monolith first. Remember the part where Noemi has to do all sorts of weird things? That's the monolith from 2001. I like science fiction if you haven't noticed that one yet. So API first is a thing, right? Microservice first is a thing. People are all excited about it. And they're good when they're good. But again, just like the other things we've been talking about, they're not good all the time. And so what I would suggest is, just like any other useful pattern, just like any other useful tool, you use them when you need them, not always. So the problem is, microservices and API first design introduce costs. And they do introduce more costs on smaller teams. So if you use these things when you don't need these things, then you're introducing costs that you didn't need to with no actual benefit. So with monolith first, what I mean is build one Laravel app or whatever you're building until you get to the point where you don't need one Laravel app. The vast majority of people who are doing API first are not doing API first because somebody actually is building an iOS app for their app right now. They say, well, we might build one down the road, so let's do API first. And then they build this hyper complicated thing. It takes them forever to do. By the time they actually end up building the iOS app, if they ever even get to that point, they have to refactor the whole thing anyway because they couldn't predict the future. So build the API for your iOS app when you're building your iOS app. And when you're not building your iOS app, don't build your API. End of story. Build a monolith, and when it's time for an API, build an API. That doesn't mean you can't think about the API that's eventually coming when you build your monolith. That is perfectly fine. And if you have very good business reality expectations that there is an API needed within 2 months, okay, cool. But that's not the same as we may build an API one day. I think we probably want to. That's not the same as there's an API team or an iOS team joining us in 2 months. So again, all these things vary, all these things flex. But if you don't know for sure that you need an API, if you don't know for sure that you need microservices, don't introduce them until you need them. Because when you do actually need them, you'll know way more about it. You can't predict the future over and over and over again. So we don't get costs when we do it this way. There's costs that come from API first, there's costs that come from microservices, so you shouldn't do them until those costs are worth the benefits. So if you're not getting benefits, don't incur those costs. You get more complicated, duplicated validation and duplicated synchronization of data between all these things. Your version control gets more complicated because you have to now synchronize the version control release of this at the same time as the version control release of that. Version control release schedules is already difficult. Now when you're having to coordinate it across multiple code bases, it's even more difficult. Your branching and deploy strategies, your testing strategies are more complicated. There's more costs up front. It is slower to develop API first. It is slower to develop microservice. And also, once you've locked yourself into splitting it out that way, well, what happens when something comes down the road later and it turns out that that wasn't actually the right split? Wait until you know, and then respond to what you actually know. Next one, seeds, not dumps. This is very easy. Don't dump production data, period. When you dump production data, you incur all sorts of costs. Instead, you should build robust, randomized seeders. So when you check your features based on robust randomized seeders, then you're going to run into problems that you weren't anticipating when you wrote the code. And you're like, oh, I never thought about the fact that somebody could be at .com.au.nz. whatever when I wrote my code. But if your production data only contains .com, then you might not run into that problem until your .co.nz.au, .com.br, whatever actually show up. Those sorts of things. There's diversity that comes from a good seeder that may not come from your production database. And it's not always not the opposite. Sometimes your seeders aren't as robust as your production data. So try to use your production data to make your seeders better. But the other aspect of it is that anytime you have production data locally, you're now more nervous. You're less likely to take risks. You're always scared you're accidentally going to send an email to 10,000 people, or you're going to send a Stripe charge to 5,000 people or something like that. So it is costly to do local seeds and make them robust. I understand it. Every single time I've talked to somebody who has production data that they're using locally is for a very, 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 very good reason. But I want to say that the costs that come from that are costs that you really need to weigh. And almost every single time I've talked to somebody in that circumstance, they have ended up deciding to do robust seeders. It takes a while to build them, but life is so much better because you now you spin people up really quickly. Actually, I have a slide for this. You can do easier CI and CD because you can actually have those seeds. You know, your tests can actually access the data. If you only have production data, then you can't have continuous integration or continuous deployment at all because they can't run their tests without seeds. Your tests are easier because you can be testing against the seeded data. It's very difficult to write robust integration tests when you don't have seeded data. New users can get onboarded without having a security check to make sure that they're allowed to have the production dump with the passwords and email addresses and personally identifying information of 30,000 users. If all they get is seeded data, then they don't need a security check and you don't have to get somebody in the organization to be able to give them that kind of stuff. People are less scared to make changes locally because they're not worried about accidentally emailing or billing people. And I just want you all to know, if this has not happened to you before, I know a lot of people who have accidentally emailed 5,000 people from their local instance, who have accidentally billed tens of thousands of dollars to somebody because of this sort of thing. So this is not just made up. This actually can happen, and people are actually nervous about it for good reason. And it reduces your fragility because it's less likely the code you write will only work if it's in the same setup as your production data. So you get a more robust testing experience that way. The next one is you should test to save your job. The best place to start writing tests is by asking yourself the question, what code, what functionality, what piece of this application, if broken, would cost me my job? And you can expand that question a little bit, like what's most likely to break? What do I have the least control over that I want to make sure it continues working the same way? What are we about to refactor, or what makes me stressed out, or what makes my client stressed out? Ask your questions about what you're going to test based on the things that matter, not based on some testing strategy that some guru taught you, blah, blah, blah. I'm not even going to get into those dramas right now. What actually matters? And then write tests for the things that matter. And there's a lot of benefits you get from this. Number one, you keep your job. That's great, because that thing that would cost you your job now has robust tests around it. Now, this does rely on you actually running your tests, hopefully setting up CI, all that kind of stuff. But still, if you have tests that cover the stuff that matters, you're more likely to not have that moment come where you're like, oh my gosh, everything blew up in production. It's my code that broke it. No, because you say, hey, look, I tested it, so we're good. You're testing because of the value that's coming from it, not because someone told you should, which means you're more likely to test, you're more likely to run your tests. People who come down the road are more likely to run your tests. They're more likely to write more tests. Tests are valuable, but testing because I tell you they're valuable is not going to happen. It's going to be this thing where you say, I'm supposed to do it just like the 20% time you're supposed to get, and you don't get any of those things, and so you just keep writing code and accruing technical debt. But if testing actually provides value, you're more likely to do it, and your boss is more likely to give you approval to do it, because you're providing actual business value that keeps everything from falling apart. You're also, when you're writing tests, you're getting your most important test first, which should be valuable, because assuming that you don't have 100% test coverage, your first priority should be the most important test next. And what's the most important test? It's the one where people fire people if that test doesn't succeed. So that's good. And finally, of course, you get to keep your job. I want to give you one example about this one. We have a code base that we work on where we have an API that has an iOS consumer that is in production, everybody's using it, and then it also has a whole bunch of local consumers. And so the local consumers under active development, and by local I mean there's either monoliths or other small like microservices that are consuming it, and then there's one API or one iOS app that consumes it. The iOS app has been in production, it's got thousands or tens of thousands of people using it, and they want it to stay exactly the same. The functions are there, the features are there, it's good. And then we're constantly making changes on the rest of it. And so one time we made one change here we didn't think would make any changes, and ended up breaking a feature of the iOS app. And so we had this idea, why don't we actually literally take all the calls that they're making and just record them and write a series of tests that just ensures that all the tests that the iOS app are making continue working. So there's a suite of tests in that code base that Samantha wrote that literally just says, iOS app makes this call, give me this. iOS makes that call. And it's sort of like the recorded stuff that she showed for Jest, where all it does is just make a very predictable call and ensure it's getting a very predictable response. So that's not our core unit tests, but it ensures that no matter what we do, we no longer have to fear breaking things for those iOS people. As long as those tests pass, we're good to go, which makes us more agile, it makes us more flexible, it makes us stress less. So these things are actually providing value to your developers, to your consumers, and to the rest of your team. All right, this one is a little bit harder to explain. It's probably not the best term for it, but one of the things I often run into is clients come to us because they're having trouble scaling. And usually the scaling happens when they have at least split their tasks out into commands or jobs or queues or something like that, but they run into a series of common problems. I'm gonna show you the slide, you'll read it while I drink. So these common problems have to do with the ability of these tasks, whether they're jobs or commands or queues or even service classes, whatever, to scale in certain ways. And these concepts right here that I'm going to go over, I don't have a computer science degree. If I got a little bit wrong, tell me later, I'll fix the slides. But I'm pretty sure this is pretty good, and I ran it by people who do have computer science degrees. So these concepts are things I want you to be thinking about as you write your tasks, especially as you think about separating out complicated and expensive and time-consuming things into queuable jobs. Imagine these four things as you're developing them and designing them. First, reentrance. If a task is interrupted, it should be able to start again without breaking. Second, idempotence. A task can be called multiple times without changing the side effects. What I actually originally wrote here was a task can be called multiple times without changing what it does or something like that. But that's the problem, is because if every single time you run that task, it inserts a new thing, and then something goes wrong and those tasks get rerun and inserts more new things, your database is not where you want it to be. So idempotence says you can run the same task 5,000 times. It made the impact in the first time, and the next 4,999 times don't do anything. And imagine the amount of times where you're like, oh, well, the morning cron ran already and it broke in the middle. Well, we can't rerun the morning cron because then it'll resend all those emails or whatever, right? And then you're like, well, we can't do that, so we're gonna miss the whole second half of the morning cron that didn't happen because this thing broke. Crap. So if you have idempotence, you know that all those tasks can be rerun without any problem. Concurrence means more than one task can run at the same time, so one task is not locking some database or something like that, which means the moment you have to go from one queue worker to 15 queue workers, you're not like, oh my gosh, we're in trouble. And the second one is a part of that too. Sequence independence means you don't have to worry that all these tasks are running in the same order. If you run throw 5,000 tasks in a queue, you should assume that they're gonna be picked at whatever order they're gonna be. 10 of them might be running at the same time, and that's not a problem. And if you do that, then you can spin up as many queue workers as you want, throw them at your tasks. Anything that you're having trouble scaling, throw it into this giant pool of things, and as long as it is these things, reentrant, idempotent, concurrent, and sequence independent, then you can just throw as many workers as you want as you can. And that's the fastest way to scale when you're dealing with a monolith, when you're dealing with a single code base, single server. So that's the first and easiest place for you to scale, rather than multiple servers and all that kind of stuff. You get easy multiple worker spin up. You don't have to worry about rerunning jobs or CROMs. And your whole thing is less fragile because it's less centered around one individual server and one individual queue worker at the same time. You now can scale these things out and flex those things out. And this is the easiest way. There's a lot of other things you can do to make it more flexible and allow more than one things running at the same time. Talk to Chris Vidal about all that stuff. I don't know all that stuff quite as well, but this is the easiest, earliest one that you can do. All right. On to refactoring patterns. I know that there's a book called Refactoring. You should go read it. I don't think any of these have the same words as some of those, but it's all very fantastic. It's also like 300 pages long, so I understand you have not all read it. So when I enter into these code bases, the most common problem I run into is controllers that are massive and controller methods that are 200, 300 lines long. And almost every single time, the things I do is I go into the Laravel actual classes. So we're talking about controllers, we're talking about commands, we're talking about things that are not popos that have been extracted in microarchitectures and all that kind of stuff. Literally just your controllers, your artisan commands, that kind of stuff. And they're massive and they're overwhelming. It's hard to understand, it's hard to call from multiple places, it's hard to reason about. And what I do is I help them refactor those things. So all these are about assuming you're in a code base where you have 100 line long, 200 line long, 300 line long controller methods and making those a little bit better. Everything that Adam taught about in his talk is one really, really, really excellent way to do it. And I'm actually going to talk about those a little bit. The service class one overlaps with it a little bit. But it's more of that same thing. We're always sitting controllers. It's a web-based framework. How do we make that code better? Oh, except this one's not about that, but it's still good. Seed every test. When you start seeding, the most common thing people do when they start seeding is to run one seeder at the beginning of their entire test suite. And then all the rest of their tests rely on that one seeder. It's okay to seed a little bit of data up front. Let's assume your entire application relies on there being a company and maybe a user. But what you should do is uniquely seed the data for each test next to the test, in the test or in the setup. You might want to use factory states or factory stories here. And so the reason for this is, when you end up doing it that way, where you seed everything once and then run all your tests, you get things like magic numbers. Right? Like you seeded one post and it has 17 comments. So some test somewhere says, ensure that post 1 has 17 comments. And you're like, where did that number 17 come from? And so you have to go back to this original seeder and hope you remember that that seeder was running and that you have to count how many, and you count that it's 17. What if somebody decides later that they want to add to that seeder another comment because they want one that has some different state? Well, all of a sudden that test breaks for no reason because it's using a magic number. You don't have to flush work affected by previous tests. The number of times I've come into a code base that does work like this, you get test halfway in that says, this test wouldn't work because this previous test had done some work that changed this thing, and so it flushes all the database tables and reseeds or something like that. You don't have to do that if you just see the data you need in that test. You don't have anything where it's like, well, this test works when we run this group, but not when we run that group. And if that group runs for that group, it works, but if it runs after that group, then it doesn't work. You don't have that, because every single thing is just seeding what it needs. And finally, if you have the data and the tests that rely on that data in the same file right after each other, it's much easier for you to reason about. So you're actually, if you think about tested documentation, somebody who joins your project, first thing they should do is read your tests, and then they read those tests and they're like, what is 17? I have no idea. And so your tests are not actually helping them comprehend the code base. So rather, they should be able to see, oh, there's 17 seeded there. I see the number 17 in the seeder. We're testing there's 17. Got it. Great. Good. This one, I'm least satisfied with this name, service classes. What a service class really is just a popo. It's a PHP object that does a thing. So you saw some from Adam earlier. He created, I think it was a checkout object or something like that. In Field Goal, which is our app that takes form submissions from static sites, we have a form object, and it represents, I think it's form, it represents basically all the data that comes in. First thing we do is spit it into a popo, and that popo has certain methods available to it. And by popo, I don't mean it's a PHP class with no methods or something like that. It probably extends a form class, but that form class is not an eloquent model. It might just be a PHP class that has some methods that give you some affordances of some sort. Also, you are able to be interesting and creative with your naming. For example, in the Nova thing that we saw yesterday, there was a class called Retrieve Movie Poster, and it was invocable, just like Adam taught us about. And what that means is he wanted a really quick and easy way to output a string. And the string was, give me movie title, give me back movie poster URL, right? It could be a closure, but just like Adam taught us about, he made it an invocable class instead. And so again, that's just a service class. And the service class can be really overloaded as a concept. It can mean 10,000 things, and usually what it means is I can't think of any other architecture pattern, so I guess I'm gonna call it a service class. So it is problematic in some ways, yet, if you have the option of either 200-line controller methods or pulling out a reasonable concept of part of what the controller is doing into a well-named PHP class that has one method or is an invocable or has 3 class methods or something like that, that just does that one thing well, you're gonna get a lot of benefits, even if it isn't a repository or a command or whatever other pattern you want it to be. Your methods are a lot shorter and they're a lot clearer. You get separation of concerns, which is a little bit of a magic concept, but it can be helpful when you have a retrieve movie poster class that retrieves movie posters. You can test it. It's a lot easier when you test it because you give a movie title and you get back a movie URL. And it's a lot clearer in the calling code. Rather than having to have 7 lines of retrieve movie poster code in line in your field definition, you get a single line that says retrieve movie poster, and if you care how it retrieves a movie poster, you can later go look at it. But you don't have to when you're looking at the consuming code. All right, custom requests. This is a little bit of an actual shape within Laravel. When your request comes in, when you use the request helper, or when you type hint request and you pull things off of it, what you're actually pulling in is just the illuminate request object. And you're calling things on it like input or only or whatever else it ends up being. And if you've seen Laravel's form requests, you've seen that you can extend those requests and do custom things with them. Form requests extend for validation and for authorization. But did you know that you can make your own and it doesn't have to just be those? You could, oh my goodness. Just making sure you were all awake. You could also, for example, make a custom request that extends request, and instead it has a prepared method. In there, you take the only fields that you care about and you do some manipulation to them. So if you want to do any work on the data as it's coming in, you might want to make a custom request and put that data in there. And in your controller, instead of type hinting the illuminate request, now hint your signup request. Because it extends the illuminate request, it's already going to get all the things that come from that. And then you just say request pair, and you prepare, and you pull it out from there. Your controllers are smaller because you've moved that code into your custom request instead of your controller. Your testing is easier. And if you have repetitive input logic, for example, you end up editing users in 5 different places in your class, you might want to put some of that code that all your user editing stuff does into that class. So that's data on the input. More commonly, the repetitive code that I see in controller is on the output. It's when you're taking your controller and your controller is sending data down to the view. So I have, I think, 4 ideas here that I want you to consider next time you have complicated controller methods that are composing data as it should be used for a specific view. So take a look at these 5, well, yeah, basically, most of the oversized controller methods are there because of the cost of organizing data for the view. So take a look at those 4, and we'll walk through each of the 4. All right, so some of these are just generic concepts. A presenter is probably a pattern of 4 of gang of whatever they are. A layer on top of another thing. It's sort of like a decorator, but a decorator just decorates like a class. A presenter decorates it for the sake of a view. So it's basically saying, in this particular view context, I want this particular thing to have some methods or properties that didn't have other places. Great, that's presenter. A view model is a plain old PHP object that you use for organizing things. So if you've ever seen Sandy Metz's 5 rules and one of her things says you can only pass like X number of properties to the view, one way to do that is to make a single PHP class that represents all the data that that view needs, put all the data into it, pass it to the view, and then the view asks for that data back out of it. So your controllers are simpler and your views are simpler, but you still have that logic happening somewhere. Responsible is an interface in Laravel that makes it possible to do view models in a more Laravel-friendly way. I'll show you in a second. And view components are something that is an idea for making VUE component-style components within our Laravel world. So this is a potential presenter. Basically what ends up happening here is we inject the post, and then you use either, there's a couple packages for this, so you probably use it, and what they do is basically say, whatever my inherent model is, the post, pass through all calls, all method calls, all property calls to that inherent model unless there's a method for it in this presenter, and then allow this to overwrite it. So one thing you've commonly seen people do is set that every single time I access the date, it should be formatted a certain way. You don't want that. You want it formatted a certain way in your views. So use a presenter so that when you're using that model elsewhere, you're not getting back the string when you actually need the carbon model. If you want a view model, it's really more just a plain PHP object, and rather than having any magic where it's passing things in, you literally just say top tasks. There's a method called top tasks. In your view, you ask for top tasks on that thing. Or if you want a progress chart, well, you make a progress chart method, and it does all the calculations to generate the data your view is going to need for that progress chart, and then you pass it in your view, and then your view says, give me VM arrow progress chart. That's it. It's just a popo. All it does is make those things available to you. But you can test it separately. You can reuse it in other places. Your controllers aren't junky. A responsible is very similar. If you can imagine taking that same kind of concept, but instead of having to pass that thing with the my top tasks or whatever else into your view, why don't you actually pass it in the middle of that same class? So responsible is an object that has its ability to convert itself to a response. You can see down at the bottom, we're not actually returning a view and then passing the responsible into it. We're literally just returning dashboard view response. And then what Laravel does is it reads the toResponse method on that, and you say, oh, prepare the data, and then you say return the view. So what we did was he took even the part where we're passing the data to the view, moved it in the class. And the cool thing about this is you can also have a remote that sticks. You can also do other checks in line. And now all of a sudden, every single one of your things using the same base responsible, or however you want to set it up, can do these sorts of checks that we all wish we had, right? Like read a particular query parameter to figure out whether it wants JSON and give the JSON response in that context, but give the HTML response in that context. Or just use request AJAX, whatever it is. There's so much clever stuff you can do here, whether it's on a single response or in a base response. All right, so I am running late because I get talked. Oh, that was the last one. Yes, I'm so proud of myself. Okay, so the payoff here. Your controllers are slimmer. The grouping and composition of your data and how your data gets passed to your views is so much clearer. It's so much more obvious, because the number one problem I see in controllers is you do a little bit of input work and then you spend the next 150 lines preparing the data that came from that input to be ready for your view. So get that out of the controller, give it its own thing, whether it's a responsible or a popo or something else like that. Have a thing that just does that thing and make your control, because remember, controllers and their methods are supposed to be traffic cops. They take input based on the query parameter and based on the headers and stuff like that, and they let something else do the work, and then they give the output. But when our controllers are 200 lines long, we're not just doing that, we're also having them be the actual actors. And so the more you can, when you're running into longer code bases and longer controller methods, allow the controller to take the input, do a little bit of work on it, send it off to somewhere else, have the somewhere else do the thing, and then respond back. Slim controller methods is going to make all your architecture a lot more flexible. And finally, you get to use fun words like responsible and HTMLable. And remember the last one, I forgot to read it off, but you get to say popo. I just like saying popo. It's just an enjoyable thing to say. It's like a highlight of my day. So if you forget everything from this code base but one thing, remember, Matt got 2 root canals. They're awful. Not everybody needs a root canal. And what I mean by not everybody needs a root canal is don't do the things until you need the things. That's the absolute core. There's a difference between preventative medicine and reactive medicine. There's a difference between preventative patterns and reactive patterns. So identify which things you'll always do, great code style, that kind of stuff, and identify which things are more templates that you will use in response to problems when you have them. It's not the same thing. The slides are not here. They will be here after Laracon AU. But if you follow me on Twitter, I guess I'll tweet them out then, I don't know. But I would love to hear more about your thoughts. I spend a lot of time on other people's code bases, but I only get access to those code bases. So what I want to hear is, afterwards, hit me up on Twitter or find me afterwards, and if there are any patterns that you find yourself regularly using to clean up your junky code bases, to fix up your controller methods, or to help yourself scale better when you're starting the monolith and you want to scale up a little bit, let me know. I'll tweet those things out, I'll attribute you, I want to make sure you get your shine, but I want to know more, because the more we understand these things, the more we spend our time doing interesting and challenging things that provide actual solutions for people, rather than spending all our time arguing about design patterns and where braces go. That's it. Thank you very much for your time.